What is up, everyone? Welcome back. As you already know, I'm Nick. This is Swiftful Thinking, and in this video, we're going to look at using background queues or background threads. Now, if you've never looked at threading before, you might not even realize that there are multiple threads in your app. And basically, behind the scenes in your app, there are a bunch of different threads that we can do processes on, that we can perform tasks on. And almost all of the code that you write into your app is going to be declared on the main thread, which is thread 1, unless you specify otherwise. And the main thread can take on a lot of tasks, but if you start developing more complex apps, you're going to end up doing a lot of stuff on the main thread. And if you do too much, it will start to slow down your app. It could cause your app to freeze and possibly even crash. So what we do as professional developers is take some of our heavy tasks that are happening in the background, like downloading from the internet, we could download images, download pictures, all of that we could put on a background thread. And basically all we have to do is tell Xcode that instead of running this on the main thread, run it on a background thread. And there are a whole bunch of background threads that we can choose from, and Apple actually provides us an easy way to access a bunch of those background threads, which we're going to look at in this video. The number one most important thing about threading is to remember that anything that updates the UI, so updates the actual screen, needs to be performed on the main thread. So as I'm going to show you guys, we are going to start on the main thread when we open our app. We are going to jump onto a background thread and perform tasks. But after performing those tasks, just before they are actually going to update the screen, we're going to jump back onto the main thread and then update the screen. So it's a little tricky if you've never learned this before, but I hope this video makes it a little clearer. Multi-threading is something that is done in pretty much every production app that I've seen, and very important to know as a developer.
All right, welcome back everyone. I am back in our Xcode project. And for this video, let's create a new file for all the code we're going to do in this video. So let's right click on the navigator, create a new file. It's going to be a SwiftUI view as always, and let's call this background thread bootcamp. Go ahead and click create. Once you're inside, click resume on the canvas just to make sure we're all connected, and let's get ready to get coding. And to begin, we're going to set up a view model for our view here. So let's create a class. We'll call it background thread view model. And let's make it conform to observable object so that we can observe it from our view. And while we do this, let's initialize a new one in our view. Let's use an @state object var. Let's call it VM for view model, and we'll set it equal to a new background thread view model. All right, let's set up our view here real quick, and it's going to be very simple because most of what we're going to do is actually in the view model. So for the view, let's create a scroll view, open the brackets. Inside, let's create a VStack, maybe with some spacing of 10, open the brackets. At the top, let's add a very simple text that says load data. Let's make it font large title, font weight of semi-bold, because that looks good. Let's click resume on the canvas just to see what we're working with here, load data. And in the view model, let's create an @published var. We'll call it data array, and it will be of type array of strings. And we'll set it equal to a blank array. We're going to then take this array and loop on it in our view. So in our view, we'll add a for each, open the parentheses. We're going to use the completion with the ID. And we're going to pass in the VM, our view model, .data array. The ID will be \self. Then the content will press enter. Get rid of this completion here and just say we'll loop on each data. So each item, let's call it an item actually. This will be each item in the data array. And it's a string, so we'll just put this text on the screen. We'll say text with the item. Let's give these items a font of headline and a foreground color of maybe red. It doesn't really matter. This is just a very simple screen here. And in our view model, we're going to create a function to load some data. We're going to say func fetch data, open close parentheses, open the brackets. And our fetch data is actually going to call another function. So let's create the other function, that's func download data. Open close parentheses, open the brackets. And this download data function is actually going to return some data. So we're going to make it return an array of string here. And in your real app, obviously this download data is going to go download something from the internet, but we're not looking at that right now. So we're just going to create some fake data. So let's create a blank array. We'll say var data of type array of string equals a blank array. And then we'll just say for x in 0 ... less than 100. And we'll open the bracket. So this is going to loop from 0 to 99. And for each of those loops, let's just call data.append. And it needs to be a string. So we'll create a string and we'll use the backslash open close parentheses and we'll pass in the x. And on each of these loops, let's just then print out the data. So this will print out the data array on each loop. And after the loops, let's just return the data. So this shouldn't be anything new to you guys. We're just going through 100 loops, adding 100 numbers to the data, and then just returning it. In our fetch data, we'll say let new data equals the download data. And then we'll say data array equals new data. While we're here, let's make the download data private so that it can only be accessed within this file. And this will be our public function, which we can access from the view. So down in our view here on the load data, I'm going to call very simply on tap gesture vm.fetchData. Okay, so if I resume the canvas, let's just make sure it works quickly and then we will check out why we're doing this. So I'm going to resume the canvas here, and if I tap on load data, it should then create our 100 items. All right, so this shouldn't be anything special, but let's actually run this on a simulator now. So I'm going to take this background thread bootcamp. I'm going to jump into our app.swift file. This should be where your app main call is. And I'm just going to make the first screen in our app the background thread bootcamp. Then I'm going to make sure we're looking at an iPhone 12 and then run it with this play button to run on a simulator. I'm going to jump back into our file quick, and I'm going to actually hide the canvas because we're not going to use it anymore. And let's look at our simulator that should have just opened up. So before I actually click anything on this simulator, I'm going to open up a new tab in Xcode that we haven't used yet. So on the navigator on the left side here, there is a little icon that looks like a spray bottle. That is the Debug Navigator. So let's click on that. And then we're going to click on the CPU tab here. And if you're following my courses, this is not something we've ever used before. But basically, this is a quick little gauge on the computing power that your app is using. So obviously this is a very simple app, and we're at 0% right here because nothing's really happening on the screen. But if you're ever building a very big and complex app, you should definitely be checking the CPU and seeing if it's high. If this bar is red and this is very high, chances are you're not doing something as efficiently as you could. And if the percentage used gets really high, your app could even start to slow down or lag or even freeze. So you really want to keep this as low as you possibly can. And one of the ways to fix when this gets high is to use background threads or multiple threads, and that's what we're going to discuss right now. So if we look down here at the bottom, there is a thread section, and this is all of the threads in our app, and you could think of these kind of as engines. So thread 1 is the main engine. It's called the main thread, and this is where almost all of the code that you write will happen by default on this thread 1. So when I click load data, it's going to loop through all of that data that we just set up and then add them to the screen. And we should see a little spike on this thread 1 here. So I have this little blue line that you can barely see. That's the current time. So we're going to look right around here, and then I'm going to click on load data, and we should get a little spike. So you can see that this happened on the main thread, on thread 1. And when I start scrolling around the screen, you'll see that all of that functionality is happening on our main thread. So this is great, and our main thread is pretty powerful. We can do a ton of stuff on the main thread without ever having problems. And you can see here, the percentage used while I'm scrolling is still only 4%, 5%. So this is not something I would even worry about in an app. And basically what happens is when you have too many tasks going on this main thread, it will get kind of stuck and it will slow down. And when the thread slows down, your entire app will start to slow down. So if you've ever used an application and you're scrolling and all of a sudden it felt a little laggy or it started to slow down a little bit, or maybe it froze for a second, that probably happened because the main thread got stuck. There was too many processes going on the main thread. It needed to just handle all those processes before the UI could continue. So I want to point out here that while I'm scrolling around, and even if I click load data to keep loading more data, all of these processes are happening on the main thread. We don't see any spikes on thread 4, and there actually could be a whole bunch of other threads here. We just have never used any of these other threads in our app, so we only see these ones. All of our spikes are on the main thread, and again, that's fine for most processes, but sometimes you're going to download data from the internet or do pretty heavy tasks. And the solution here is to offload some of these tasks to a background thread. All right, so let's jump back into our file. I'm going back into the background thread bootcamp. And I'm going to go up to our view model here, and this function download data is getting called right here. And I'm going to put this on a background thread this time. So all these print statements are going to happen on the background. So Apple actually gives us a bunch of background threads that we can use that are super handy. So here I'll call dispatch queue .global, and we can use the regular global completion here, or we can use the global and specify a quality of service. Let's start with just the global, and then we'll call .async, and all we're going to do is put this code into this thread. Now, when we put our code into this async closure here, we're going to get these error messages that we need to reference self.explicitly. And in the next video in this series, I'm going to explain what this self is and how we can use weak self to better manage this. But for right now, the easiest way to think about this is when we call this async, this code here inside this closure is happening on a different thread, right? So when we just looked at all of our threads, I'll go back to it. Normally we're on the main thread, but now we're going to go on a background thread. We're going to go on a different thread. So when we go to another thread, we basically need to ensure that we still have a reference to this class, which is referenced on the main thread. So by calling self dot, it basically creates a strong reference to this class, so it knows that this download data is actually in this class here. So very simply, we'll just add self dot, and I'm going to explain that more in detail on the next video. But for right now, we just added this dispatch queue.global, which is a background thread, and we're going to call all of this code on the background thread. So when we print this data, it should be happening on a background thread. And this is going to throw a warning error when we run it, and I'm going to run through that in a second. But for right now, let's just take this code, let's rerun our app, and we're going to try this one more time. I'm going to jump back into the CPU page here. All right, so you saw before that when I clicked load data, we got a bump on that main thread. But this time when I click load data, it should open up a background thread here. So if I click it, we should see a spike, and this spike was on thread 3. And if I click load data a bunch more times to keep calling that function, it should keep happening on background threads. So we can see thread 11 down here is now doing stuff. And this is slightly better because we've offloaded some tasks from the main thread onto this background thread. Now, two things I want to point out here that are very important. The first thing is that when I move around the UI, it is still on the main thread. And this is important because anything that affects the UI needs to be done on this main thread. So in our situation, when we're on a background thread, we could download data and we can manage data. But if we're going to do something that updates the UI, the front end of the actual application, we need to go back onto the main thread. So on your Xcode, you probably got this purple error message here that you've probably never seen before. And if I click on it, it's going to bring me back into where our issue is. And it very directly says publishing changes from the background thread is not allowed. And just as I was talking about, we can go and download data on background threads and process data and move data around, maybe save data in our application or to our database. But if we ever want to return back and do something that updates the UI, so in this case, if we update the data array, it's going to update the view here. So anytime we update this data array, it needs to be done on the main thread, not on the background thread. And that's why we're getting this error. So very simply, before we update the data array, we will go back onto the main thread. And we do this by calling dispatch queue.main.async. So it's almost the same call here. This was a global, this is the main. And main is that thread one that we've been looking at. And I'll just put this code into this call here. So we'll go to the background thread, download the data on the background, and then when we're ready, we're going to hop back onto the main thread and then update the UI. So now when I run it, we shouldn't get this purple error message anymore. I'm going to press run again. I'm going to go back into the CPU page here. We have our load data, and if I click it, we should get a spike on a background thread. And that happened on the main thread because it was updating, but we should have also done some stuff on the background. So I'm going to click it a bunch of times and see if we can get some spikes. All right, so you can see that some of the processes are happening on thread 3 here. And of course, some processes are still always going to happen on thread 1 because after we go to the background thread and we download the data on thread 3, we're going back onto the main thread to update the UI. So that's why thread 1 is also running as well as thread 3. And I want to dive into this a little bit deeper because we can use other threads instead of just thread 3 here. So if I go back into the code, we called global. But we could also call global with the quality of service. And this is super handy that Apple gives us. If we press the period on this quality of service, there are a couple different background cues that we can use. Going down this list here, the first one is a background. And it gives us a nice description here that this background choice should be used for maintenance or cleanup tasks that you create. So this could be things that maybe you need to do in the background that the user doesn't even know about. Then we have the default quality of service. We have a unspecified, which is not specifying which one you actually want to use. We have the user initiated option, and this is pretty interesting. This class should be used for tasks that prevent the user from actively using your app. So it's almost like scary to read. So this should be used for things that are so crucially important that the user can't even use your app until this loads. So user initiated I would use for like the most important things, but also use it sparingly because if you're doing something that's going to prevent the user from actively using your app, you don't want to run into a situation where your app is actually frozen because this task is running and it's preventing the user from clicking around. We also have the user interactive, which is for tasks such as animations, event handling, updating your app's user interface. So this is a pretty common one to use. And lastly, we have the utility, and this is for tasks the user does not actively track. So offhand, I find that I use this utility mostly for things that the user doesn't even know is happening. So stuff that I've added into the app that I want to perform, but the user doesn't even know those functions are running. So of these, let's just use the background one for now. And this time when we run it, it should actually put these tasks on a different thread than thread 3, which we saw last time. And I'm going to go down here to the view real quick and just make this VStack. Let's make it a lazy VStack so that a little bit less operations are happening on the view. And let's run our app one more time. Let's jump into the CPU. And we have our load data, and when I click the button, hopefully a new thread will open up in the background. And when I start clicking the button, I'm going to click it a bunch of times here. We can see that some of the processes are happening on thread 4. And then when it's going back onto this main screen, it's happening on thread 1. And it looks like it even opened up a new thread halfway through this. We're now on thread 9 and also thread 1 as well. And if I scroll around, all the UI stuff is still happening on thread 1. So we can see all the spikes on thread 1. But when we're using that download data, it is happening on thread 9. So I know this kind of seems anticlimactic because all we're doing is looking at these little tiny spikes, but this is crucially important when you start doing heavy processes, because if you're like downloading something from the internet, especially if it's a video or a movie or a picture, those are heavy processes that you want to put on background threads. You don't want to run those on the main thread. But after you download all that data, you need to go back onto the main thread to update the UI. So that's kind of what we simulated here. And the last thing I want to show you guys before we finish up this video is a quick little check that you can do in your app if you're ever curious on what thread you're on. So there's a very simple way of checking whether or not we're on the main thread. And we can do that by calling thread.isMainThread. This will tell us whether or not we're on the main thread. And similarly, we can call thread.current to get the actual current thread that we're on. So I'm going to actually just print these out so that we can see what we're doing. So let's print, let's call this check1, and then we'll print thread.isMainThread. I'm going to copy and paste it, and here we'll print thread.current. Then I'll copy both of these and paste them also down here, and let's make this check2. So let's run the simulator one more time, and this time when we go to download that data, we should see these check ones, and because we're on this background thread, this should be false, this should be not thread 1, and then when we go back onto the main thread, isMainThread should be true, and then current should be 1. So let's open up the console here, let's click load data, and for check 1 we have false, and the thread is number 4. So this is not on the main thread. That's this check here. And then we return back onto the main thread and it went back to true, which we can see here, and thread is number 1. Alright guys, I hope that wasn't too confusing. I know it was a lot of me talking for just a little bit of code, but these background threads are crucially important. This is something that I wish someone had told me more about when I was learning how to code, because if you don't know about it, you'll end up doing all of your tasks on the main thread when it would be much more efficient to offset some of that payload onto background threads. The number one main important thing here to note is that you can do tasks on the background thread, but if something is going to affect the UI, if it's going to change the screen, you need to do that process on the main thread. If you're still confused, do not worry, because we're going to start using these threads a lot more in the next couple videos as we start to download data from the internet and manage that. So I hope you guys are as excited as I am. Thank you all for listening. As always, I'm Nick, this is Swiftful Thinking, and I'll see you in the next video.